Professor Bialis here. In this video we're going to be talking about section 11.5 where we graph quadratics using transformations. We talked about graphing quadratics when we dealt with, I believe it was 8.2, when we were graphing just nonlinear functions using a table of values. What we're going to be doing here is talking about ways that we can interpret the equation itself to tell us where the graph should go. Okay? Typically when we talk about a quadratic and we think of it as a function, we think of it as that ax squared plus bx plus c. Okay? We're going to graph that format in 11.6. What we're doing in 11.5 here is looking at that quadratic in a different form. Okay? And that form is a times the quantity x minus h squared plus k. Okay, now notice we still have that a value. A is still a. That first number you see is going to be your a value. But instead of a b and c, we're going to have what's called an h and a k. Now, when we're given in this form, all we need to do is interpret that a, the h, and the k, and then we can jump right into our graph. We don't have to do any table of values. Okay, so this is a very powerful form of graphing once we know how to interpret everything. Now, I'm going to show you first how we interpret that a, h, and k. Let's start with the h and the k. The h value, if the h value is bigger than 0, now that means it's positive, then we are going to shift the graph h units to the right. Okay? If the h value is negative, we are going to shift h units left. Okay? Now, remember, we're going right or left. What goes right to left? That's your x-axis, right and left. What is the h next to? It's next to the x. Okay, so h tells you go left or right. If it's positive right, negative left. That's it. Okay? K value. If your k value is positive, we are going to shift k units up. If your k value is negative, less than 0, we are going to shift k units down. Okay? So that h value is kind of grouped with the x, so we think it's moving along the x-axis. The k value is kind of a standalone outward calculation for the overall output. The overall output is y. Okay, so that's why we're moving along the y-axis. Positive up, negative down. Okay? Now, the a value. There's a lot of little nuances with the a value. First of all, if a is less than 0, meaning it's negative, I don't care what number it is, but it's negative, then we are going to have a vertical flip. We're going to flip that graph vertically. What that really is a reflection about the x-axis, but we're just flipping it. That's really what it comes down to. Okay? Now, before I get into the other parts of a, this quadratic equation, when we graphed it in the past, what did we expect? We expected a U shape, right? We expected a graph that looked something like this. When I say I shift it, I'm literally taking this graph and I'm shifting it left, right. I'm shifting it up, down, okay? If I were to flip it, I would flip it so it looks like this. It's an upside down U. Now the other stuff that happens with A is what's called a stretch or a compression. A stretch would be like as if I'm pulling that graph up and it goes like this. Okay, sometimes we say it's getting skinnier, okay? But we're stretching it up. If I compress it down, it's going to go like this and it gets wider. Okay, so that's what the A can also do. Not only can it flip the graph, but it can also do something like this. So when do those things happen? If the absolute value of A, now I'm putting absolute value because all I care about is the number itself. Okay, if it's negative, that's a vertical flip. Okay, but the number itself, if that A is bigger than 1, okay, now bigger than 1, what does that mean? Bigger than 1 is like you're multiplying by a 2 or a 3. What happens to a number when you multiply by 2 or 3? It gets bigger. It stretches up. So that is going to be a vertical stretch. Okay? And then if that absolute value of a, we don't want to say less than 1. We want to say less than 1 but bigger than 0. Because again, we have to be bigger than 0 because of absolute value. So it's like a half or a third. Then we have what's called a vertical compression. That's what those letters, those variables will be telling us. Again, h is taking this general quadratic, shifting it like this. K value, shifting it like this. A value can flip it, it can stretch it, it can compress it. Okay? Now the other thing I want to point out here is, notice the h. I defined h for when we're bigger than or less than 0. Did I say anything about 0? No, because if I add or subtract a 0 here, that doesn't do anything. So that has no effect on the graph. Same thing with k. If I add or subtract 0, that doesn't do anything. So why even talk about it? It's just no change. The a value, what did I not define? I didn't define 0 because if I multiply this by 0, it's not quadratic anyways. Okay? But I also didn't define 1. Okay? I didn't say when it's equal to 1 because if I multiply by 1, that doesn't do anything. That's the multiplicative identity. Okay? So when there's a 1 for an a, there's just no change. When there's a 0 for either of these, it's just no change. Okay? So let's jump into some examples. This is all that you need to come to the table knowing. Okay, so I would definitely write this down, have it on a sheet of paper. As you're getting used to this, reference it. The more you look at it, the more it's memorized up here. You don't have to force that. Okay, if you just sit there for 30 minutes, I gotta have this memorized, it's gonna be a stressful situation. But if you just use it and you run through as many problems as you can, it's gonna get stuck up here very easily. Okay, so this is what we need to know. Now let's see how we're gonna make these happen. Now, depending on your instructor, they may have a different way of you analyzing this. This is how I personally like to do it. Okay, it's the same basic ideas, it's the same result, it's just a different presentation. Okay, so if you do have a different instructor that has you do this differently, please follow their instructions, and then maybe it'll give you a different perspective even than how I'm presenting here, and that's never a bad thing. Okay, so let's go into something like this. Let's say that. Okay? Now, the first thing that I always have my students do is identify the A, the H, and the K values. Just give me the numbers, okay? Now, if it helps, first thing, write that over it so you can see the A, H, and K lining up, okay? Now, the A value, remember, is a multiplier in the front. If that multiplier is unseen, it's understood to be a 1. So A is 1. The H value, it was x minus h. So x minus 3 tells us h is 3. Always pull out the opposite sign for that h. I see a negative 3, I pull out a positive 3. If this was a plus 3, I would be pulling out a negative 3. And then the k value, it's plus k, so whatever you see is what you get. So I'm going to say negative 5. Okay? The next thing I want you to do is very simply state what that does to a graph. If the a is 1, remember that wasn't really talked about because if you multiply by 1, you don't do anything. So I'm just going to say no change. Sometimes I'll also just kind of draw a line next to it. Don't leave it blank though, because then it looks like, well, I didn't know what to put there. Okay? Either draw just a line like nothing or no change. Now if h is 3, remember h tells you to go left or right. Okay? And if h is positive, we're going right. And then k is up and down. If it's negative, we go down. Okay? One other thing that I want you to always put on here is p of x. Now, what the heck does that mean? Okay? I call it p of x because this is what we call our parent function. When we get into like a college algebra, you're going to be doing this a, h, and k stuff with any kind of function that there is. It's not just going to be quadratics. So I want you to get in the habit of writing this, because in college algebra, when we're opening the door to anything, it's important to identify this. But what we have right now, what happens to our function when we strip away that a, h, and k? If I strip away the a, h, and k, I just have x squared. So my basic parent starting function is just x squared. That is the simplest quadratic I can encounter. Okay? So that's what I always want you to kind of tack on the end to remind yourself of that. Now, I'm talking about shifting and stretching and compressing. What are we shifting? We're shifting this parent function. Always start with that. Okay? So if I were to graph that, x squared, just regular x squared, I have 0 squared is 0, 1 squared is 1, go back, 2 squared is 4, go back, 3 squared is 9. I can do that on the other side. When I square these negatives, I get the same results. Okay? Now, I want you to start your graph always by graphing this, because I want this to just get embedded in your head. I want you to know this like the back of your hand. But when I graph it, I'm going to use a dashed line just to remind myself this was just for reference. Okay? Now, when I actually graph this using those transformations, always start with your h and your k. Okay? When I start with my h and k, I'm going to go always to this. Remember, this right here is called a vertex. Okay, so just real quick. This bottom piece here is a vertex. If you end up with a quadratic like this, the vertex would be right there. Okay? So start with that. I am going to shift 3 right, 5 down. So, use this red here. I'm going 3 right, 5 down. There's my new vertex. Now here's the thing. That a value doesn't do anything. So every point I could go 3 right, 5 down. 3 right, 5 down. I could do that point after point after point. Or I can look at this pattern and simply bring it down. Now what do I mean by that? When I graphed this originally, what did I do? I went right 1 up 1, right 2 up 4, right 3 up 9. I should be doing the same thing here. Okay? I want you to get used to doing it that way, so when we change this, it's a lot easier to handle. Okay? So, from this new vertex that I got with my h and my k, I can then do the normal pattern of right 1 up 1, right 2 up 4, right 3 up 9. Okay? And notice, I went right 3 down 5. Here I went right 3 down 5. Here I went right 3 down. That translation is still going to be there, but I didn't have to count every single one of them. Same thing. Left 1 up 1. Left 2 up 4. Left 3 up 9. Notice these points are on the same level. That can help you make sure that you're on the right track. And then this is my final graph. When we were doing this back in section 8, or chapter 8, we would just have to blindly start plugging in values until we got that U-shape. Now, if we can interpret these correctly, we know exactly where that graph is going. Okay? And again, we're going through this slow right now, but as you get better at this, this will take you a few seconds. You can do this in under a minute, no problem. Okay? So, let's do a few more. that is pretty much it for this section. Again, we're going to go through more examples to see when things change up here and there, but this is it. This is all there is to this section. Let's say we have f of x equals that. Very simple looking function, okay? But when there's less there, we got to make sure that we're looking at all the different components. Remember, a is that multiplier out in front. There's just a 1 when there's nothing to be seen. I could say no change or just nothing. Okay, some way notate that. H is always grouped with that x. There's nothing there. So what can I just not write when I'm adding? I can just not write a 0. I don't have to put plus 0 or minus 0. So that's a 0. Okay, again, H value goes left and right. If I have nothing there, no change. The K value is that value that's hanging out on its own at the end. That's a positive 3. K is always up and down, and since it's positive, I'm going up. What's my basic function that I'm graphing? This entire section, it's x squared. And we got that. Okay? Start with this p of x. 0 squared is 0. Then I go right 1 up 1, right 2 up 4, right 3 up 9. And guys, I want you to be doing that enough where you're like, oh, I gotta do it again. That's where you want to be. That means it's getting stuck in your head. This is like, okay, I do it again and again. I want you to feel that. I want you to feel the repetition so you can just, boom, not even have to think about it. That's my parent function. I'm starting with this, and then I move my vertex with my h and k. Okay? Guys, my vertex is always 0, 0 to start. If I then move that this many units left and right, this many units up and down, that's essentially where my new vertex is. That's why this A, H, and K form is typically called vertex form, because your vertex is staring you in the face. If I go 3 up, 1, 2, 3, notice 0, 3, that's my ordered pair for the vertex. Okay, so this A, H, and K form is vertex form. Now, after that, that's the only move that I have to make. I just go up. So I'm moving all those points up, or taking the standard pattern and copying it from this new vertex. Right 1 up 1. Go back, right 2 up 2, 4. Go back, right 3 up 4, 5, 6, 7, 8, 9. Notice I just went up 3. Same thing here. Here, here, here. And there's my new graph. All I did was take my original graph, where I knew where it was going to be, and I went, brought it up 3 units. End of story. Let's look at another one. Let's say that. Okay. Clean up the graph here. Okay, so first get the numbers. My A value out in front is a 2. My H is a 4. My K value is a -3. Again, H you always take the opposite sign, but the K value, you see what you get. Okay? Now, when A is 2, okay, when A is 2, that means it is bigger than 1. Think of multiplying by 2, that is making something bigger, so we stretch that value. So this is a vertical stretch. H value goes left and right. When it's positive, we go right. k value is a negative. K value goes up and down. Down when it's negative. And p of x always x squared. Okay? Again, take your time with that. There's really no work. It's just all up here. But take your time with it, because if this is wrong, there's no hope for the graph. Okay? So next thing I graph is my parent function. So I go that 0, 0, 1, 1, go back 2, 4, go back 3, 9. Other side, same thing. Dotted curve, because again, this is just for reference. Okay? Now, even when I have a stretch or a compression going on, I always want to start with my h and k. So I have a new vertex of 4, negative 3. That goes from 0, 0. I go 4 right, 3 down. So I get my 1, 2, 3, 4, negative 3. There's my new vertex. Now, this is why I wanted you to start thinking like, okay, just copy the pattern 1, 1, 2, 4, 3, 9. Okay, because now I can adjust the pattern using that a value. Okay, so what does that look like? Normally, from my vertex, I'm going right 1, up 1. Then I go back. I go right 2, up 4. I go back. I go right 3, up 9. Okay? Now, this was a vertical stretch. So those vertical moves get stretched up by a factor of 2. How do we do that? Simple. Multiply the verticals by 2. That's all there is to it. Okay? This is not something you have to guess through. You literally just lay out your initial pattern, 1, 1, 2, 4, 3, 9, and then you multiply by that a value. If I multiply by 2, it makes it bigger, so therefore I'm stretching it up. So 1 times 2 is 2. 2 times 4 is 8. 9 times 2 is 18. That's it. Nothing more to it than that. Okay, so now as I'm doing this graph, from this new vertex, normally I would go right 1, up 1. But now I go right 1, up 2. Instead of right 2, up 4, I go right 2, up 8. So 2, 4, 6, 8. Instead of right 3, up 9, I go right 3, up 2, 4, 6, 8, 10, 12, 14, 16, 18. And then the other side, same thing. Instead of left 1, up 1, left 1, up 2. And I go over 1, I just go to the same height. Notice I'm aiming for that height. If you do a good enough job on that first side, I'm just going to go here so I can see where that's going. Then, got this. Whoops. Caught the line there. And I got that. And there we go. And notice, what did I do? I took this original one, I went right down, and then I stretched it, made it skinnier from here to here. Okay? That's all there is to it. That's why this pattern is so important to have down. Right 1, up 1, right 2, up 2, or up 4, right 3, up 9, because then you're just adjusting that. And it literally comes down to multiply, multiply, multiply. Nothing more than that. Okay? Don't overthink it. Even when there's a fraction, I'm going to show you a fraction here in a second. Don't overthink it. Just multiply and move based on those numbers. End of story. Okay? Let's look at another one. And also notice I'm erasing everything every time. Like this parent function, I'm erasing every time because I want you guys to see it and I want you at home to go through it every time so it gets stuck here. Again, if it starts to feel very tedious and repetitive, that's a good thing. That's where you want to be. Okay, that means it's working. Okay, let's say we have let's say that. So our a value is 1/3. Our h value is with the x, so that's just a 5 in this case. And our k value, there's nothing being added or subtracted, so that's just a 0. Okay? Parent function always x squared. Now that a value of 1/3, okay, it's positive, so there's no flip, okay, but it's a 1/3. So if I multiply by a third, do I make it bigger or smaller? Okay, I'm making it smaller, so that is a vertical compression. Okay, the h value goes left and right. Since it's positive, I'm going right. And if the k is 0, that does nothing to the graph. Again, you could write no change or whatever. Just specify that it's doing nothing. Okay? Now, let's go into the parent function. Parent function starts 0, 0, 1, 1, 2, 4, and then 3, 9. And then I go the other way as well. Dashed curve. So again, you know that that is just there for reference. And then I still start with my h and my k. My new vertex is 5, 0, or 5 right, and then we stop. So I take my old vertex and I go 2, 4, 5. And there's my new vertex. Okay. Now, the vertical compression. What should happen is my normal graph gets pressed down. Normally, from my vertex, I go right 1, up 1, then I go back, and I go right 2, up 4. Notice I'm still at that vertex right here. Then I go back and go right 3, up 9. I'm changing this vertically. So I am going to multiply by that a value of 1/3. Okay, no big deal. 1 times 1/3 is 1/3. 4 times 1/3 is 4/3. I would write that as a 1 and 1/3 though, just so we can wrap our brains around that. So 1 and 1/3. And then 9 times 1/3 is 3. Okay? Now again, don't let the fractions freak you out because you're literally just going up that number of units, nothing more. Approximate the best you can. It doesn't have to be exactly perfect because this is not a perfect thing that we're doing here. If we wanted it perfect, we would need very fine instruments, or we would need some sort of computer program to do this. We're not doing that. We're just trying to understand where this thing's going. So what I'm going to do from this new vertex is I'm going to go, instead of right 1 up 1, I go right 1 up about 1/3. I go back from the vertex, right 2 up 1 and 1/3. Go back, right 3 up 3. Okay, and now instead of muscling through those fractions again, copy it over, copy it over, copy it over. And now look what I get. Now, could I get more points going off to the side? I could. But since we're typically sticking with 1, 2, and 3, let's just stick with those. Okay? Now again, notice what I did. I took my original, I went 5 right, and I compressed it down, making it a little wider. Okay? Now I keep saying vertical compression, vertical stretch. There is a horizontal compression and stretch. We don't see very often though, because if you think about it, if I vertically stretch it up, isn't that also a horizontal compression as I'm squeezing it here? Or if I compress it vertically down, I could think of it as a horizontal stretch. So typically those horizontals can be translated into verticals, which is what we're doing here. Okay? Let's do one more example. Let's say we have a negative 3. Let's say negative 4/3. And then x plus 3 squared minus plus 2. Let's say that. Okay? So, a value, negative 4/3. H is negative 3. K is 2. Okay? P of x, always x squared. Let's do the h and k first. H goes left and right. Since it's negative, we're going left. K goes up and down. Since it's positive, we're going up. Okay, let me clear this off. Now the a value, there's actually two things going on here. It's negative. So what we have is a vertical flip. Again, technically that's a reflection about the x-axis, but I just think of it as flipping down. Also, you have the 4/3 part of it. Now, a lot of times you see fractions and you think fraction means compression. That fraction is bigger than 1. Okay, so this actually is a vertical stretch. So that one number has two different transformations attached to it. The vertical flip part, and then we're stretching it based on the value of the number itself. Okay, so we'll get to that in a second. First, same as always, parent function. Let me translate it here, here, and here. This is what we're starting with. Okay? Now, we then go back into the vertex. So vertex is simply 3 left, 2 up. So from here, I go 1, 2, 3 left, 2 up. And I could think of it as negative 3 comma 2. There's my vertex. Okay? A value is a negative 4/3. So this is where we again go back to our standard 1, 1, 2, 4, 3, 9. And just like before, we multiply by the a value. So we're multiplying by negative 4/3. Negative 4/3, negative 4/3. Okay? This gives me negative 4/3. This gives me negative 16/3. This gives me, if I reduce, negative 12. Now negative 12 is pretty straightforward, but the negative 4/3, okay? Negative 4/3, if you want, you can say negative 1 1/3. Negative 16/3 you can think of as negative 5 1/3. Okay? Now, let's translate that into here. Guys, these are just directions on how to go left, right, up, or down. The fact that it's negative tells you to go where? Down, okay? That's where the flip comes from, because instead of going over and up, you're going over and down. Simple as that. We should be able to predict that there's a flip from looking at that number. But if we are not sure, do the multiplication and go where it tells you to go, and it'll show you where or what should be happening to this function. Okay? So I'm going from this new vertex. Instead of right 1 up 1, I'm going right 1 down 1 1/3. Instead of right 2 up 4, I go right 2 down 1, 2, 3, 4, 5 1/3. And instead of right 3 up 9, I go from the vertex right 3 down 2, 4, 6, 8, 10, 12. And that's it. Okay? This is not something you need to calculate fractions in your head. Do the multiplication, move according to the directions. And then I go the other side. So instead of right 1, down 1 1/3, I go left 1, down 1 1/3. I go left 2, down 5 1/3. I go left 3, down 12. And notice, these should come out aligned horizontally. If they don't, something's wrong. Okay? So then I connect those dots. And then what I did was I took this original I shifted it 3 left, I flipped it down, and then I stretched it. So okay, original, I went 3 left, flip it, stretch. Okay? So again, there's not much going on here, especially when you start stretching and compress. It's just multiplication, nothing more than that. Okay? But what I want you guys, as a big picture kind of idea here, is once we pull these numbers, we interpret those numbers, it's just translating them to the graph. You have your vertex with the h and the k, and then we shape it according to that a value. This gives us the location, essentially. This gives us the shape of it. When we get into 11.6, what we're going to do is bring this function here back to that ax squared plus bx plus c. But remember what I said at the beginning of this, a is a. A is not going to be anything new. That b and the c can then be used to get the h and the k. And once we do that, then we're back to what we've been doing here. Okay? So if you drill these processes here, 11.6, very, very simple. But we'll talk about that next time. Okay? So don't overthink this. Draw your parent function every time. Know this pattern, 1, 1, 2, 4, 3, 9. That's never going to go away. And even when you get into the college algebra application of this, where you bring in absolute value function and square root function and all those other ones, each of those functions will have their own kind of pattern involved. And then when you mess with the a value, you just multiply with it in that pattern. Okay? So keep working hard. Let me know if you have any questions, and I'll see you next time.